Okay, try to imagine a world without electricity. And I mean really imagine it. No lights, no computers, no phones. Now, what if I told you that one man, a man with basically zero formal education, changed all of that? This is the story of Michael Faraday, a bookbinder's apprentice who somehow figured out how to bottle lightning and, well, electrify all of civilization.
To really get the scale of what this guy did, you have to picture the world he was born into. A world where night was truly, deeply dark, lit only by fire. Power didn't come from a socket in the wall, it came from massive steam engines, from the muscles of people and animals, from the wind.
I mean, the leap from one to the other is just immense. We went from a world completely defined by physical, mechanical limits to one powered by this invisible force, a force just flowing through wires. The change was so fundamental, it's honestly hard to wrap your head around. Faraday didn't just improve the old world, he built an entirely new one from the ground up.
So, how does a revolution like that even start? Well, for Michael Faraday, it didn't begin in some fancy university lab. Nope, it started in the back of a dusty old bookbinder shop. He was born poor, gets a job as a bookbinder's apprentice. But here's the thing. He wasn't just binding the books, he was devouring them. Science, chemistry, physics, he read everything he could get his hands on. And then, the turning point. A customer gives him tickets to a lecture by the scientific rock star of the day, a guy named Humphrey Davy. Faraday goes, takes these incredibly detailed notes, binds them into a beautiful book, and sends them to Davy, basically as his resume. And it worked. Davy hires him as a lab assistant, and with that, the fuse was officially lit. Once he was in the lab, it really didn't take long for Faraday's genius to find its focus. He got completely obsessed with this mysterious link between electricity and magnetism, and that obsession led to his first, truly monumental breakthrough. This was the question that just haunted him. See, at the time, scientists knew that an electric current could create a magnetic field. But could it work the other way around? Could you actually generate that invisible power, an electric current, from nothing more than a simple magnet and a coil of wire? And then, in 1831, he cracked it. The answer was a resounding yes. The secret wasn't just having a magnet near a wire. The secret was motion. By simply moving a magnet through a coil of wire, he made an electric current appear out of thin air. He had discovered electromagnetic induction, and with it, he'd basically found the engine of the entire modern age. And look, this wasn't just some neat lab trick. This single principle is the foundation for almost everything that powers our lives. We're talking about the massive generators in our power plants, the electric motors in our cars and blenders, the transformers on every street corner. It all comes back to this simple, beautiful idea. And the core idea is so elegantly simple. You spin the magnet faster, you get more electricity. What's absolutely incredible is that Faraday figured all this out through pure experiment. He wasn't a mathematician, he thought with his hands and his eyes, just letting nature itself reveal its laws to him. But he wasn't done, not by a long shot. After connecting magnetism and electricity, he turned his brilliant mind to another great mystery, the relationship between electricity and chemistry. So he starts running electric currents through all these different chemical solutions and discovers two incredibly simple laws. First law is pure cause and effect. The more juice you use, the more chemical reaction you get. Simple. But the second one is even more profound. Electricity isn't random. A specific amount of charge will always produce a specific predictable amount of chemical change. He was literally decoding the hidden language of atoms and electrons. And why should you care about this? Well, these laws are the reason we have modern batteries. They're why we can plate metal with chrome or gold. They are the basis for making hydrogen fuel from water. The guy pretty much laid the entire foundation for the field we now call electrochemistry. And through all this meticulous work, he stumbled upon something amazing, a specific number, a constant of nature. It's now called the Faraday Constant, and it's this universal value that precisely links the amount of electric charge to the number of atoms in a reaction. It's one of the fundamental pillars of modern science. Just incredible.
So let's just pull back for a second and look at the sheer scale of his legacy. We are not talking about small, incremental improvements here. We are talking about a complete and total reinvention of the world.
You know you've done something extraordinary when a mind like Albert Einstein's holds you in that kind of esteem. And there's a reason for it. Einstein's work on relativity was built on the concept of fields in physics. This idea that invisible forces, like magnetism, exist in the space around an object. Well, that whole idea, It was pioneered by Faraday. He was the first to truly visualize these invisible lines of force that fill the universe.
His work isn't just stuck in history books. It is everywhere. It's in the light bulb over your head, it's in the motor of an electric car, and it's inside the very device you're using to watch this right now. Faraday's laws are constantly running in the background of our civilization, 24/7.
But the story gets even more incredible when you look at the man himself. Because in an age that was all about titles and status and wealth, Faraday was, well, he was a complete outlier. Think about this. He was offered a knighthood, incredible wealth, and the presidency of the Royal Society, the highest scientific honor in Britain. He turned it all down. He even refused to be buried in Westminster Abbey alongside kings and queens, choosing a simple grave instead. For Faraday, the discovery itself, that was the only reward he ever needed. He didn't need statues carved in stone. His legacy is alive. It's dynamic. It's the quiet hum of the transformer outside your window, it's the charge in your phone, it's the light that pushes back the darkness every single night. That is the real monument to Michael Faraday.
You know, other scientists discovered pieces of the puzzle, but Michael Faraday saw a pattern that no one else could. And in doing so, he didn't just discover laws, he discovered the future, a future powered entirely by his unrelenting curiosity.